Hello kiddos, welcome to Math in Minutes. In this video, we are going to learn what is ratio, why do we need ratios, how are ratios helpful in our day-to-day life, and in the end of this video, we will learn to solve some word problems related to ratios. Before I tell you what is ratio, kids, can you please count with me the number of stars and hearts which are visible on the screen? 1, 2, 3, 4, 5. There are 5 stars and 3 hearts. This kind of comparison of how much of one quantity to the other is called ratio. Here we are comparing the number of stars, that is count of stars to hearts, but we are not comparing stars to hearts. So ratio can be defined as comparison of similar quantities or values. We use the concept of ratio in many situations of our daily life without realizing that we do so. A real life best example of ratio is cooking. That is, we use the concept of ratio while adding ingredients in cooking. For example, to make rice, for every 1 cup of uncooked rice, we add 2 cups of water. So, the ratio of ingredients to make rice is 1 cup of uncooked rice 1 is to 2 cups of water. 1 is to 2 is the ratio. Also kids, I repeat once again, here we are not comparing rice and water, but we are comparing the quantity of rice and water required, that is 1 cup of rice to 2 cups of water. Similarly, to make rotis, for every 3 cups of flour, we add 1 cup of water to make dough which can be rolled into rotis. So, ratio of flour to water for making rotis is 3 is to 1. Ratio is represented by colon and read as is to. Kids, let's check our understanding with the activity which is visible on the screen. There are 4 apples and 2 kiwis. Now tell me what is the ratio of apples to kiwis and what is the ratio of kiwis to apples. Please let me know the answer in the comments. Not only while cooking, we use ratios to solve many day-to-day problems like to compare heights, weights, cost, distance, time, and so on. Now let's get into solving word problems. Example 1. Find the ratio of 90 centimeter to 1.5 meters. As per the definition of ratio, we have to compare values of same type or quantities of same unit. Here in this question, the two quantities are not in the same units. Therefore, first we have to convert them into same units. In this problem, we are going to find out the ratio of 90 centimeters to 1.5 meters. In order to find the ratio of two quantities, both the quantities should be in the same unit. Here we have 90 centimeters and 1.5 meters. So let's convert 1.5 meters also into centimeters. So 1.5 meters is equal to 1.5 into 1 meter is equal to 100 centimeters. So we will multiply 1.5 with 100. 1.5, this 1.5 is the decimal. Let us convert it into fraction. 1.5 can be written as 15 by 10 into 100. Now let's simplify this. 10 ones are 10 tens are. 15 into 10 is equal to 150 centimeters. Now we have both the units, both the quantities in same units. 90 centimeter is to 150 centimeters. Now this ratio can also be expressed in the form of fractions. 90 divided by 150. Now let's simplify this ratio. You can cancel 0, 0. You will be remained with 9 by 15. If you see, both numerator and denominator can be divided in 3 table. So 3 threes are 3 fives are 3 by 5. Therefore, the required ratio is 3 is to 5. Let's look at example 2. Give two equivalent ratios of 6 is to 4. We can get equivalent ratios by multiplying or dividing the numerator and denominator by the same number. Let's see how to do that now. This ratio 6 is to 4 can be expressed in the form of fraction 6 by 4. Now let's try multiplying the numerator and denominator with the same number. Let's multiply with 2. 6 into 2 and 4 into 2. 6 twos is 12 and 4 twos is 8. Now let's try dividing numerator and denominator by the same number. 6 divided by 2 and 4 divided by 2. When you divide 6 by 2, you'll get 3. When you divide 4 by 2, you'll get 2. So now the equivalent fractions of 6 by 4 are 12 by 8, 3 by 2, or equivalent ratios of 6 is to 4 are 12 is to 8 and 3 is to 2. Let's look at example 3. There are 45 persons working in an office and the female employees are 25 and the remaining are males, and we have to find out the ratio of females to males and also the ratio of males to females. In this problem, they didn't mention the actual number of males. So first we have to find out the actual number of males, and then we have to find out the ratio of females to males and also the ratio of males to females. Let's go ahead and do that. Number of females is equal to 25. Total number of workers is equal to 45. So the number of males will be total number of workers minus number of females, which is 25. 45 minus 25 is equal to 20. So number of males is 20. Now let's find out the ratio of number of males to the number of females. Number of males is 20 is to number of females is 25. If you see, both can be divided in 5 table. 5 fours are and 5 fives are. So the ratio of number of males to number of females is 4 is to 5. And also the ratio of number of females. Number of females is 25 to the number of males is 20. Again, you can divide both 25 and 20 in 5 table. 5 fives are, 5 fours are. And the observation from this example is, if you see, the ratio 4 is to 5 is not equal to 5 is to 4. Let me quickly summarize what we have learned so far. Ratio is used to compare values. The values which we are comparing should be of same type. For example, we cannot compare weight of a person to the height of another person. We have to compare weight to weight or height to height. Since we are comparing quantities of same unit, ratio has no units. Last but not least, ratio should always be expressed in its simplest form. Thanks for watching. See you again in my next video.